implement the declaration function instructions. Let's say there are two of them, so that is wait a minute, yeah, decv and decp. Decv is declaring a variable and decc is declaring a pointer, or declaring a pointer, as well as there is a third one too. That is, third one is for declaring a array, dec a, right? Here we can see a spec out here. Move it out this side. Okay, a little bigger. Right, this one. Okay, down there we've got a dec a. Alright, dec a. So dec a and dec b. Alright, so we've got our these. Well, let's see. Let's make a change. You know, we don't really need this dec b. You know, because we can just have a ptr type, or rather, we can just use int here. We can just use int here. You know, that's enough. That's enough. Dec b. Let's just reduce one more instruction if possible. You know, that's a better way. Right. Dec v. What dec v does is, whenever it encounters dec v, the next thing will be the variable name. The next thing will be the variable name. So next, let's first allocate this AST node. Then next token. What will be the next token? Next token will be where we will take the data rather than taking it in buffer. Since it's going to be the name, we are sure of that. So why not take it directly in node data and string? All right. The next thing is the then we have to do again next token buffer, because this is the data type. You know, data type, there are, let's say, 3 data types: int, character, and buffer, and double, right? So hash define data type int 0 1 2 3 int, then I got double, then I got character, lastly I got array. let's just say it's an array for now, array, and let's just wait for a minute. Okay, now we can say that boolean parse data type character const, because let me make it const because I'm not going to modify this inside this function. So type name, again I'm saying I'm not going to check for errors. Like if there are errors, it might crash. So we're going to just make it work for compiling. It will just compile if the correct code is there. So if, alright, this is one thing, and one more thing is this is void, and this will be a struct ast node data ast statement data pointer data, right? We're gonna pass in the pointer. So if strcmp of type name and let's say what, integer int equals to 0, that's one thing. Now if I just copy paste this thing out here, sorry, alright, and else integer, then double, and lastly else what is that, character, and the last one else if else this is going to be printf unknown data type, because we don't know the data type, because we have 3 data types, 3 known data types. We are just going to block the unknown data type and exit with a bad status, with a bad exit code, right? The failure exit code, that I guess it's 1 or -1. It's 1, right? Now the next thing is, what if it is int? So what exactly we'll do? First things first, data dot instruction is equals to okay, dec c, dec v. Let's just remove dec v from here, or make it dec a. Dec v, or rather, let's not bother ourselves with instructions. So let's say int value equals to the data type. What will be the data type? The data type will be data type int. So this will be data type double, this will be data type character, again data dot charval. Let's just do this. This is small because there are going to be only 3 data types, right? So storing it in character value will be more efficient. Well, character itself is just an integer, like 1 byte integer, right? So that's done. Now next thing is the size of the data type. For example, well, let's just keep it like this for now. We'll add more if we need. Again, for now, I'm telling. Out here in the code where we are parsing the token DexB buffer, then so let's say node data instruction equals to DexB. Alright, node data, parse data type buffer. We're going to pass in the buffer and the statements data, right? So what it's going to do is whenever we're passing in the data, this is going to parse the data type and detect data type and store it in there. All right. So first here we are parsing the deck. Whenever we are the instruction we are facing is DexC, we are going to parse a new AST node, add a new node for that instruction, and then we are going to take the data variable name and the variable data type and then process it. All right. The next thing is DecA. DecA is going to be pretty much the same. For example, this, let's just copy paste this again. Now the important thing out here is this is going to be DecA for first, and secondly, I've got a semicolon out here. And secondly, we're going to call next buffer again, and we have the size of the array. So where will we store that? We will store that in data dot inval. That's why I freed this. Rather than that's why I use charval for storing the data type thing. So we'll be storing the data type out here. So it will be, let's see, A to LL, I guess. Or let's do A to I itself because LL, A to LL, then it will be buffer, right? Now A to LL is for reading the contents of the string. The buffer is in string format, right? So A to LL just converts that into a integer format. Alright, so we have got our buffer and that statement is done. DecA is also done. Our DecA is also done. Now variable declaration are done. So let's move on. Now next thing is this statement, right? Now let's just first implement the put as these statements with keywords first because that's more interesting, and then we'll slowly move on to statements like this. All right, first then we can just see we have done func, we have done end, we have done like you have to do puts. Now there will be several of them. For example, this is copy paste this out here. All right, let's just add an error out here because this is an obvious error. And keep it there. Unknown. Well, this might be needed later on. This is puts. I mean, puts is there. Let's just add one few more. Where is puts? Alright, puts is out here. 14. 1 for 14. Put C. Put I. Put T. Alright. These four are putting putting all the primitive data types as well as the putting a string. Alright, that's important. Now, with this we can modify this and write own functions on its own. Now puts will be let's say let's just do it with all of them first. Put S, put I, put D, put again what was that? Put C, right? Alright, so it's going to just add an instruction. Alright, so we are just going to do this one. Alright, okay, forgot something important out here. You remember, add child. I have to add a child node to the no current node. Alright, add that as a child node. Now same thing out here. Alright, where am I adding that? Add child. Alright, let's just move this up now. Alright. Alright. Now I'm going for an add child. Out there, here, up here too. No, not current node, but then we'll just do it. Add child. Node, right? So we can just say that add child will be called like that. Okay, we don't need current node out here, we just need to call node. And we're adding this to the statements list, right? For example, we're adding each of this to the statements list, the children list. And in case of func or things like that, the thing itself is also a part of the children's list, alright? Now, next thing is to test. How to do that? Node. Well, this does not need any parameters, so we can just ignore that. And then character, or rather instruction equals to test. Alright, add child node. Alright, this is done. Alright, this is done. And then here it will be put I, here it will be put B, here it will be put C. Alright, we've got our primitives, we've got our put functions. Now let's do something for the if else if thing, right? Or rather, while would be easier. While would be easier. It would be easier. Now, exactly what we'll be doing? Let's see. First things first, how exactly is a while loop going to be considered? While loop is itself a scope. Now in that scope, the first statement is this. Alright, the first statements, first n statements will be this, and then there will be the while body. So that's going to be a rule. So let's just make it. For example, let's make it while out here. Keep it a while. While. Now, if we encounter a while, we'll be creating a new node. Alright. Now you have to call, like you have to follow the entire process like this again, you know. So let's just do node parent. Well, I forgot one thing. Node, or rather, whenever we are doing add child, out here, add child node dot parent equal to current node. Alright, we're just automatically setting the parent to, because you know setting up parental relationship in this case is important. Alright, we are creating the node. Now node dot data. Wait a minute. We're going to keep adding that. For example, add child node, another node, then again current node equals to node, right? Now one more thing in this case is node dot data dot character val equals to 0. If character val is 0, then that means we are still in parsing this area and not the main while body. Alright, so that is an indication of that, right? Now you're just going to continue parsing. We're going to add children to it, and else if strcm. Now the same thing is going to be happening for if2. right? You can see the same logic is going to be applicable for if too. Let's find the if else statement out here. If, right? If the same logic is going to be applicable, then my thing is, it's the issue is with else ifs, right? Else will have an issue, so let's just face it for now. Somehow let's just wait for that. Now let's do it with if. So with if, now one more thing, node data dot instruction equals to while, I think I did not do that, and there data, alright, 15, the while loop, like that is also an instruction out here. So while loop out here, we have done that, and now we're parsing that while loop. We've done that. Then for if also we need an instruction, I guess. I don't have an instruction for if. If else if, that's 16, or rather let's just keep if make it 17 out here, make it 16 out here. Now if it is if, then we'll do node data dot instruction equals to if. Alright, now if there is a then, right? Else if, one mistake is there, that is you have to do it with check the equality with 0 to compare the strings. I just did this, but that is wrong. I have to check the equality with 0. Alright, so I have let's see, like whenever we are encountering an if, we'll wait and let these statements be passed in. Once these are parsed, we'll encounter a then, right? Same is for while too. If we're going to encounter a then, so in that case, whenever we are encountering a then, what we have to do is it will be then whenever we are encountering a then, what will we do? Rather than creating a new node, because that is not exactly a node, we're just separating it, we're just segregating it, So rather than creating a new node, the current node dot data dot character val equals to 1, this is to symbolize that we have gone into the body of the thing, body of the if else or while loop, whatever, right? And the next thing is int val is equals to current node children count, the number of instructions out there. That's important, because you have to, like, while implementing the logic, while either implementing an interpreter or the code generator, we need this, how many instructions are out there, how many statements are out there. Then this is done, then is done. Alright, now next thing is we have to check for if else is. Now I'm not going to implement else if at this moment, because again that's going to be pretty much complicated. So let's just keep it up to else. Alright, if and else. Alright, so if it is, and this is going to be 2, or rather 1. Wait a minute. Then again, if this becomes else, if the current instruction is else, what should we do? What that means is we have not encountered the end, so we are just going to do this as 3. Alright, so whenever we are encountering the else, we are just going to say current node dot data dot whatever double val is equals to, let's say, well, we don't mind it being doubled at this moment because, you know, yeah, we can just transform it back into an integer. We just need the value. Alright, we're just taking the number of things in if body, and then we can just start adding things in else body. That's it. This thing and this thing is really meaningless, but I'm keeping it now for future use. Like this, these flags might be used in future to determine whether which state is it, which part of the if else if or while body we are in, while a structure we are in again. And this is all what we need. We're just taking the value of the children count, like the number of statements in that part. All right. So with that, we have almost implemented if else and also while loops. The next thing I want to implement is one more thing is, whenever a function is out there, let's say we have got a function in there, that means you have to assign a specific ID to that function, you know, that is important. So for example, static struct, let's say static, let's create a struct again. With this struct, let's say a string int pair, and we'll have a character buffer, say 4096, and a int 64 TIT. Alright, or rather, let's just not do that at all. We don't need function IDs because we are going to implement it in C, so function IDs are not going to be that crucial part of that. So let's just ignore it. We'll ignore anything that is not very, almost like not important, like not very important, because we are trying to make things simple. Now, next thing is return. Again, it will be pretty simple. It's just going to add that instruction as a new AST node, for example, like exactly same as put C. It's exactly same as put C. Alright, so what we'll do is return, and it will be return. Again, I did not make it. Now this is a bad habit to, you know, just name macros like this. It's very bad. You should ideally make some prefix, like for my project it should be Zord return, or rather Zord or instruction return or something like that, but let's keep it like this for simplicity's sake for now. Alright, we've got our return function. That's one thing we have to change up here. I am seeing a bug is this has to be normal, right? This is a normal statement. These two. No, while is not normal statement. Put C is. This is not really required that much, you know. We're not going to use that. It's just there for reference for some reason if we need it. Alright. The next thing is somehow implementing a parsing these stuff. For example, now let's write some other helper functions that we'll need while performing these, while trying to parse these things. First, boolean is operator, or rather integer, or rather boolean is operator character C. Now what we'll do is return C equals to plus. Now we are not going to support multiple characters, like multiple character operators or very complicated stuff. It's simple, it's meant to be simple, right? So we are not going to support all that. Just these four are enough. We don't even need brackets and stuff like that because of our design of our programming language. So be rest assured, we still can do a lot of stuff with this thing, right? Now this is operator. The next thing is whenever where are we? Yeah. Object returned. After that, we have to go for the next one. That is, it is neither. Wait a minute. Now one thing I just want to do is, again, the syntax for calling a function should be a bit more changed because, you know, this looks better, right? Call. So in that way, this thing we built this thing we built will be changed to a bit. For example, this will become call func1 4. Alright, 4 and call 4 and ll func2, and here it will be 45 and call func out here. This will be 3, right? 3, we're going to call that function out here. 45 and that 3 we call function 2, and then again 45 and 3 call function 1. That's it. So this is going to be changed at this. It's quite the same, you know. It's quite the same. The call and function possessions are reversed, and this looks, you know, a bit more interesting and will be a bit easier to parse, right? Let's see. Let me show you. The next thing is call. The next thing we implement is call. C-A-L-L, call. We are implementing call like this because it will be like a minute. I just made call to be in front of the function name, just so that we can get the function name like that, like we did with variables. For example, let's just go back and take A or take B, whatever. This one will, let's go down again. Now you can see this is way more simpler to get the next name like this, rather than having call the name before and the function call later. So we have got that, and then data still. Then we don't need anything else. We don't need anything else. And we're just gonna add the child to the current node, right? That's done. Next syntax we want to implement is the operators, right? Now else if buffer is equals buffer, no, let's title whether the length of buffer strlen buffer equals to 1, and what we call it, where is it the function, yeah, is operator of buffer 0. That's the operator of buffer 0. I mean, you know, it's there. So what we can do is it's operator. In that case we have to just pushing the operator 1. So let's just copy paste this thing first. Alright, now this is not required. Data node data dot instruction is equals to what? CLL call. Now call, I guess, is not yet implemented out here. Alright, let's just create that call, right? Now we have done our function call. I mean, yeah, we are calling the functions. Next thing is placing, let's just add the name of the function too, right? That's important. Name of the function will be loaded with this next token, that is. The next thing is variables and pushing numbers and stuff. Now we need to find whether a number is a digit or not, whether a string is a number or not, right? So to do that, what we can do is, alright, where is that? Alright, let's do it here. So we need to check whether a token is a integer, or like whether it is a number or not, or because like whether it is a number or not, like it's going to be easy. So static boolean is number pointer buffer, right? We've got our buffer and I have to check whether it's a number or not. So how do we do that? For example, for I is equals to 0, I is less than say str len buffer I plus plus. Result is equals to 0. Alright, result plus is equal result. Alright, if not is digit. If not is digit, alright, of not is digit of buffer I and okay, if is digit of, well, what is number is not number I, if not digit of is number I, or if buffer I is equals to the dot point, because in case of decimal numbers this dot will be required. So if that is not a digit, or if and it is not equals to this, so it will be return false, and in the end we are going to return true, right? We've got our is number function. So if it is a number, we have to check whether it is a decimal, integer or float, right? Characters are not going to be entered directly. Characters can only be taken from strings, I guess. Or rather, let's see. Let's say Boolean pointer is double. I mean, now you can just write this. Now if is double and then buffer if this and buffer wait a minute, yeah, if and then double and buffer I is equals to dot, then is double equals to true, right? We are setting the value of is double to be true, otherwise it's false. Now that's important. If let's set it to false at first. If is double equals to true, right? We are setting the value of double to be true if it has a dot in it. Now it can be multiple dots. Again, I'm not checking for errors. Like it will be automatically removed with C's number parsing system. Now we have called that. Again, you have to check if else if is number of buffer, then you have to do is number of buffer again. Now we are not going to let me tell you again, we are not going to have characters directly. Characters will be used from strings, right? So we can have a boolean out here to check for whether it's double or not. The boolean is double is equals to false, right? Now out here you have to pass that into as a parameter, so it is double. Alright. Now if is double, then well, let's just create a node first. Now the next is if it's double, node data dot instruction. Instruction will be from here. That is wait a minute. Out here the instructions will be pushing that item, right? Pushing that item from into there. So you can say push var, push ptr, push all the types of items are there, right? You can push it into the stack.